Lightning. Here we go. This is the topic we were supposed to do when I decided to do the hockey video.
Okay.
Lightning. Just explain lightning a little bit. You know static electricity? When you rub your socks on the carpet and you touch something metal and you get zapped?
Yeah.
That's basically what lightning is. Just cranked up to 1,000,000.
There's a lot more stuff rubbing together, I guess.
Yeah, it's what happens with lightning is electricity is the movement of a negative charge. It's the you remember electrons from when we did our periodic table video? What electricity is the movement of electrons going from a negative source to a positive source.
Like charges attract.
Yeah. Opposite charges attract.
This is why I'm struggling.
What lightning is basically just you've got all these clouds, gas particles, dust particles, all this kind of stuff flying around in the atmosphere, bumping into each other, rubbing each other. That kind of sends electrons free and throws them out all over the place. Right. So you get this massive clumping of negative charged electrons in clouds. So
and then they're not happy.
Build up all of this negative charge, and they want to get rid of it. Yeah. Electricity really wants to go to ground state, and when it comes to
the clouds aren't about that negative.
When it comes to the earth
and they want to ground themselves.
When it comes to earth and the weather, there is no grounder state than ground itself. That's why lightning hits the ground. It's because electricity, the clouds are negatively charged, the ground is positively charged. All those electrons in that cloud want to get to the ground. So what they do is they send feelers out throughout the sky. There's just these streams of electrons going throughout the sky, and as soon as one of those feelers hits the ground, everything sucks back up and shoots down there. And that's what a lightning strike is all those electrons traveling from the cloud into the ground.
Along that little feeler path it made.
Yeah.
That's so cool.
And that's why lightning is jagged. Because it's electrons doing random movements until they hit the ground.
Each feeler probably has like little prongs going off it too, and it just takes the whole path probably.
Yeah.
That's cool.
And what you see, because electrons are so fucking tiny, you can't see them. It's impossible to see them. They're quantum particles. You can't see them. But when you see a lightning bolt, what you're seeing is the gas molecules around the stream of electrons getting superheated and charged and turning into plasma. So when you're looking at a lightning bolt, you're looking at plasma. And the thunder crack that comes from lightning is the shock wave that causes. Because all this gas gets rapidly heated, it also rapidly expands faster than sound, which causes a loud boom.
And then light travels faster than sound.
So you see it before you hear it. Yeah, so that's what it is like you get a sonic boom from the gas molecules expanding. That's what the thunder is.
Cool.
Yeah. And that's why they quite often hit trees. Because trees are high up in the sky and very broad, so it's a big tall target for the electrons to hit and then flow into.
And it's like easier finding the trees than the ground.
Yeah.
And that's also why you should lie down on the ground in a thunderstorm.
Yes.
Because it'll be more likely to hit a tree that's taller than you.
Also, if you're lying down, there's not as much surface area to get hit by the sonic boom to push you away.
Oh, really?
Yeah.
If it hits close.
Yeah.
That's cool.
That little line right there is a lightning rod. Yeah. It's next to your house. That is a terrible house. Your neighbor's
house. That is a squid.
That's a better house. Your neighbor's house is over there. Right. He doesn't have a lightning rod. Yeah. He gets hit by lightning, you don't. Yeah. Because the lightning rod is a long, thin point of a very conductive material that can bleed off the electrons before they congregate into a lightning bolt.
It's like a better tree.
Yes.
It'll prefer it over anything else.
Slowly bleed off the electrons so that it doesn't release a shit ton of energy all at once in a lightning bolt.
Oh, wait, so they're not to get hit?
No.
They're just to bleed off.
Lightning rods don't get hit by lightning. They bleed off the charge so that lightning doesn't strike in an area around them.
Oh, that's cool.
Yeah.
Huh. I always thought lightning rods were meant to get hit and like take the hit for the other stuff. But
No.
Cool.
And like he said, like Bryant said, when you're outside, if at any point you're standing outside and your hair starts standing up on end and you have no idea why, fucking run. Get in a car, in a shed, in a house, anything. Just get out. Get inside something. Yeah. And if you can't get inside something, get as low as you can.
Get low. Get low, get low, get low. Because guess what? That's the static, right?
Yeah.
Probably.
That is the positive charges in your hair reaching up. Or it's also like electrons going into your hair, and since your hair is light enough, the electric force from those electrons trying to go somewhere can pick your hair up.
Yeah. Actually, that kind of explains why it's like a different feeling. If you've ever like rubbed a balloon on your head and it's like the static, it feels different from like your hair raising up in like fear or whatever. Because that's
when you get goosebumps, that's your body raising the hair up on it.
Body reaction versus
your hair actually getting pulled by something.
Because the static, it makes your hair feel really light.
Yeah.
Yeah, it's weird.
It's cool.
Yeah.
So that's lightning. Really cool. Real simple. It's actually a lot more simple than you might think. Some people might think. It's really cool. I love it. Also, something that a lot of people might not know about, if you've got like a volcanic eruption, and it's spewing that big fucking cloud out into the sky, that actually causes lightning storms, because in those clouds you get a lot more material rubbing against each other. It creates that static charge that lightning needs to fly off.
That makes sense, because it's like it's coming from a source as opposed to like clouds are a gathering of stuff. Yeah, right? So it's like a more concentrated cloud.
It's just making a more concentrated cloud where more gas molecules are compacted in a small area, can bump into each other, create static charge. And that's why you get lightning storms when a volcano erupts.
Huh. Cool.
I ain't gonna fucking talk about ball lightning though, because I have no clue what that shit is.